This is called the 90-degree thing is called the normal one. Okay. This angle of incidence is denoted with I, and angle of reflection is denoted with R. Okay. This ray will be called incident ray. This ray, after striking this and go back to the same medium where it is coming from, this is called reflected ray. And this is plane mirror is placed on the bottom. Okay. Now I read this one and I tell you what is the phenomena of reflection of light and what is the difference between reflection and refraction. So first of all, we will restrict to the reflection of light now. I'm going to read this. Reflection of light is illustrated in figure 12.1. You can see this figure. This is related to the reflection of light. This figure is related to the 12.1 figure is related to the reflection of light. When a ray of light when a ray of light from air along the path AO, look, this ray of light, this incident ray, this is ray of light is coming from the air. When the ray of light from air along the path AO, because it is going the path AO is coming from air on a plane mirror and it falls on the plane mirror. This is called the plane mirror. This one, the bottom line is called where M is written. This from here to here, this is called the plane mirror. When the ray of light coming from the air, which is the path of ray is called AO, it strikes on the plane mirror. What happens? It is reflected along the path OB. After striking the plane mirror, it will go back to the path OB. This is called reflected ray and this is called incident ray. Again, the ray of light, the path of a ray of light, which is called incident ray AO, when strike on the plane mirror, and it will reflect back to the same medium. It is reflect because it is coming from the air, and after striking the plane mirror, it is reflected back to the same medium, which is air. This is called reflected ray. This is called incident ray. The angle between incident ray AO and normal N is so this angle. So I will say this angle normal. The incident ray angle with the normal, which is making angle with the normal, this is called incident angle. And when the ray of light after striking this will go back to the same medium, the angle between this reflected ray and the normal is called angle of reflection, and it is angle of reflection is noted with capital R, small r, sorry, or angle of incidence is noted with small I. So I will say angle AON is called the angle of incidence represented by I. The angle between the normal and the reflected ray OB. The angle between the normal, this is normal, and this is reflected ray OB. This angle is called R. So this angle is called angle of reflection, and this angle is called angle of incidence. The angle between the normal and the reflected ray OB, which I will say NO and B. Angle of incidence is AON. This angle. This angle is AON. This angle is called angle of incidence. And NOB. This angle is called angle of reflection, and it is denoted with small r, or angle of incidence is denoted with small I. So we can define the phenomena of reflection as, so if they ask you define the angle of reflection of light, so you will write this definition. When light traveling in a certain medium, falls on the face of another medium, surface of another medium, a part of it turns back in the same medium. Look, when a light traveling in a certain medium, this light is traveling in a certain medium, this is falling on the plane mirror, falls on the another medium, and a part of light, it turns back in the same medium. It is going back in the same medium. OB this is going back into the same medium. It's coming from here, and it is OB, the part of light is going back to the same medium. This is called an reflection. This phenomena is called reflection of light. So this is the definition. You got to memorize this, and when you write this definition, just make sure you make the diagram as well. When you write this figure, make the diagram as well, so they know what is the angle of incidence, what is the angle of reflection, what is normal. and what is the plane mirror. So now I'm going to study the laws of reflection now. So uh, these are the laws of reflection. So what the laws of reflection say, the incident ray, the normal and the reflected ray at the point of incidence all lie in the same plane. So an incident ray, this is the incident ray, this is normal, and this is reflected ray. These three, incident ray, reflected ray, and normal, lies in the same plane. If, for example, if they are on the page, so these three things, an incident ray, reflected ray, and normal, lie on the same plane. Suppose you have a table in front of you, so it means incident ray is striking, and the normal and the reflected ray, they are all lying on the table. So they are all lying in the same plane. So the angle of incidence is equal to the angle of reflection. When you study the phenomena of reflection, you got to remember this: the angle of incidence, this angle I will be must be equal to angle of reflection. Not reflect, I'm not talking about reflection, phenomena of reflection. I'm talking about reflection. Whenever you see the phenomena of reflection, in this case, angle of incidence, it must be equal to angle of reflection. Suppose this angle of incidence is AON is 45 degree. So NOB is also 45 degree. You got to remember, if it is 50, angle of incidence 50 degree, then angle of reflection will be 50 degree. They must be equal. Angle of incidence equals to angle of reflection. You got to remember this in the phenomena of reflection of light. You got to remember this: angle of incidence must be equal to angle of reflection. And the second, first is angle of incidence, angle of reflection, and normal. They all lie in the same plane. These two laws are called the laws of reflection. What are the, I repeat, angle of incidence, normal, and angle of reflection? They lie on the same plane. And the second one, angle of incidence must be equal to angle of reflection. Suppose angle of incidence is 45 degree, then angle of reflection will be 45 degree too. And you got to remember that this is only true when there's a phenomenon of angle of reflection. So I'm now moving towards another thing. So types of reflection. So I will study the types of reflection now. So what are the types of reflection? Types of reflection, we will study two types of reflection. One is called the regular reflection, and one is called the irregular reflection. There are the two types of reflection. One is called regular reflection, and one other is called irregular reflection. So what is regular reflection? If the incident rays strike on the smooth surface, so the reflection through this smooth surfaces, the reflection caused through the smooth surface is called the regular reflection. But we have seen in practical life that the surfaces are not smooth. They must have they are rough naturally. If you microscopic view, you will find these surfaces are rough. So when the incident rays strike on it, so they go randoms. They go randomly. They do not go like this, because these are the regular reflection and this is irregular reflection. Look, the incident ray strike on this rough surface, and after striking it is going this way. After striking it is going this way. After striking it is going this way. So this is not the smooth surface. This is called the rough surface. So there are the two types of reflection. One is called the regular reflection. Another one is called the irregular reflection. Regular reflection, the reflection formed by smooth surface is called regular reflection. Look, if this is going smooth, they are going in the same direction. And this is generated from the smooth surface. But the reflection caused by or generated from irregular surfaces or microscopic, and practically all the surfaces are not smooth; they are irregular. So when the incident ray strikes on them, so they do not go in the same pattern. They do not follow the same pattern. They go disorderly. They go, one is going this way, one is going this way. This is called irregular reflection. So we discussed about regular reflection and irregular reflection. So this is the end of the topic 11 and 12.1. Now I'm going to start the topic 12.2, which is called spherical mirrors. If you open page number 38 of your 10th class book, you will find this topic 12.2, which is called spherical mirrors. You will find spherical mirror. In this spherical mirror, I will make sure what we will study. We will study concave mirror. As I told you in the starting of my topic, starting of my lecture, I told you first of all we will discuss about mirrors, and after this we will study about lenses. Then we will find the difference between mirrors and lenses. What is actually the mirror? What is actually the lens? So first of all, we will study the mirror. We restrict ourselves on the topic mirrors. So 12.2 is related to the spherical mirrors. Okay. So so we have two types of mirrors. One is called the concave mirror, and other one is called the convex mirror. So you should know. Before I'm going to summarize with a few terms related to the mirrors, right? So this is called the principal axis. The straight line goes and passing through the mirror. This is called the principal axis, the straight line. This is called principal axis. C is called center of curvature. The center of curvature is noted with cap. C. Radius of curvature. So, you know that if you consider the consider the circle, so circle has a radius. Similarly, this mirror is a part of the sphere. This mirror is part of the sphere, so it must have a radius. So radius of curvature is denoted with capital R. Center of curvature is noted with C, and radius of curvature is denoted with capital R. And this point is called pole. This point we will discuss this thing in detail, but you should for the time being you should familiarize with a few terms. What I'm talking about: principal axis, radius of curvature, and center of curvature, and then the pole. You should know when you if I take the example of the circle, so you know the circle has a center. So in this case, we are saying center of curvature. But in circle we say this is a sphere. The sphere is a three-dimensional, and the circle is a two-dimensional figure. So this you should know very clear about this. What is the difference between sphere and what is the difference between circle? So sphere is actually the three-dimensional figure, while the circle is the two-dimensional figure. So only two axes are involved, x or y. But in sphere, x, y, z, t, c, d, three-dimensional are involved. So when I talk about, I'm just relating the circle with sphere. So when you consider example of circle, you find that there is a center, and center lies in center. So it is noted with C. So circle must have a radius. So it is noted with R. A circle. So the end point of the circle is called circle here pole. And in this case, sphere is called pole. So the line passing through the straight from the radius from the diameter center is called the principal axis. So now I'm considering about the sphere. So this is the sphere. So in this case, this straight line is called principal axis, and this C is called center of curvature, and this is called radius of curvature, and this is the end point. This is called the pole, and this is called aperture of opening. So radius of curvature, center of curvature, principal axis, and poles. So this is called, you should familiarize with these terms. Again here, this is convex mirror. So I will tell you what is the difference between concave mirror and the convex mirror shortly. Principal axis is, this is pole again, this is principal axis, and this is aperture, and this is radius of curvature, and this is center of curvature. Okay. Now I'm moving towards with what is the difference between concave mirror and the convex mirror. So first of all, I read the concave mirror. This is the concave mirror, okay? A spherical mirror whose inner curved surface is reflecting is called concave mirror. This is the definition of the concave mirror. A spherical mirror, because it is the part of the spherical mirror, if you break down, if you it was the first part of the sphere, that's why it is called a spherical mirror. If you cut this, it will form the mirror. It will call the concave mirror. And if the inner side this side which I'm pointing, if it is reflecting and outside is polished, outside polished with red lead oxide paint. If we polish the outside and leave the inner side as reflecting, this is called the concave mirror. A spherical mirror whose inner curved surface. This is the curved surface, right? This is the curved inner one. Inner curved surface is reflecting is called the concave mirror. In concave mirror, the size of the image depends on the position of the object. Both virtual and real images can be formed by the concave mirror. I will show you what is the real images. If you have a spoon in your hand, there is a curved surface of the spoon and there is the outer surface. The curved surface is called. If you take your face in front of the mirror, you will say you can see your face opposite side. You're inverted. Your face is inverted. It's mean real images form. So both virtual and real images form in concave mirror. The if you take this example of the spoon, the curved space where we eat, where the surface where we eat from, that is called the concave mirror. The outer surface is curved and inner surface is polished. Inner surface is reflecting and outer surface is polished and polished with the red lead oxide paint. This is called concave mirror. And in concave mirror, both virtual and real images can be formed. Now I'm talking about the convex mirror. So in this case, inner surface is polished. This inner surface is polished, and outer surface, this surface is called reflecting. This type of mirror is called convex mirror. This type of mirror is called convex. This is the definition of the convex mirror. A spherical mirror whose outer curved surface is image is reflecting. This outer surface is reflecting, and inner surface is polished. So this green color shows it is polished, and it is polished with red lead oxide. Okay. In convex mirror, the size of image is always smaller than the object. You will see that the size of the image, if you see your face, the image will be smaller than the object. In this case, in case of you are the object, and if you see in the convex mirror, you will see the image of you will be smaller than the object. Only virtual and erect image is formed by convex mirror. I will show you what is when we go ahead. I will tell you what is virtual and what is erect image. Now we will consider pole. This is the pole. This point, this center point is pole. Now, if they ask you what define pole, you will say it is the midpoint of the curved surface by a spherical mirror. It is also called vertex. This is also called vertex. This is the midpoint of the spherical mirror. This is the midpoint of the. How will you define pole? This is the midpoint of the spherical mirror. So this is called pole. The other name of the pole is vertex. Center of curvature is denoted with C. C is the center of curvature. A spherical mirror is a part of sphere. The center of the sphere is called center of curvature. As I have already told you. So circle has a center. So in the midpoint, the center one is called the center. So this one, the spherical mirror is a part of the sphere. The center of the sphere is called the center of curvature. Now I'm talking about radius of curvature. So if you look at radius of curvature, this is not with this one, this R, capital R, this is the radius of curvature. Now I'm explaining you radius of curvature. Radius of curvature, it is a radius of sphere of which spherical mirror is a part. Again, the same thing. Principal axis, it is the line joining center of the curvature and the pole of the sphere mirror. Look, this is called the principal axis. This one is called the principal axis. This is going to till the pole, and it is line. It is the line joining center of the curvature. It is passing through the C as center of curvature and pole of the spherical mirror, and it is going to pole. The principal focus. The next point is principal focus, and principal focus is denoted with capital F. There is a small f and there is a capital F. First of all, I will tell you about principal focus, and this is denoted with capital F. After reflection from a concave mirror, rays of light parallel to the principal axis converge to a point F is called the focus. This point is called focus. If you look at this figure, figure 12.5 on page number 39, so of the 10th class textbook, this point is called, this is the concave mirror. So when the parallel ray of light strike the mirror and it pass through the focus point, is passed to the point. Look, this is the parallel ray of parallel light. After reflecting, it is passing through the F it focus point. This parallel light after reflecting the concave mirror, it is called, it is passing through F. Again, this is passing through F. This is called the principal focus, and principal focus is denoted with capital F. So after reflection by a concave mirror, this is the concave mirror and this is the convex mirror. This is the example of the concave mirror, figure of the concave mirror, and this is the figure of the convex mirror. So I'm talking about concave mirror. After reflection from a concave mirror, ray of light parallel to the principal axis. Look, why this is ray of light parallel? Because this is principal axis, and this principal axis is parallel to the this ray of light. Because the railway tracks are parallel to each other. They never meet each other. That's why the railway tracks are parallel to each other. Similarly, principal axis, this line is parallel to this light rays. So this is parallel to the principal axis. Converge to a point F because they are meeting at the same point. That's why converge other name is called meeting at a point. Okay? The point is called the principal focus. This point is called principal focus and is denoted with capital F. Hence, concave mirror are also called converging mirror. The other name of concave mirror is called converging mirror. Why I am saying converging mirror? Because after when the rays of light reflect on the concave mirror and it converge at meet at a point which is called the principal focus. So that's why it is called converging mirror also. The other name of concave mirror is converging mirror. Since rays actually pass through this point, therefore it's called the real focus. So because they are on the same side of the mirror, that's why it is called the real focus. Capital F, it is noted with real focus. Converging lens, this is concave mirror is also called converging lens. Now I'm talking about convex mirror. This is convex mirror. This is a 12.5b figure is the convex mirror. So in case of convex mirror, rays parallel to these principal axes after reflection appears to come from a point F situated behind the mirror. Look, so I told you in the convex mirror, the outer surface is reflecting while the inner surface is polished. So when the rays of light pass through this and it reflects on the same side, and if we extend these lines, these reflected lines on the back, so they seem to appear from the focus point. This is called capital F. This is the case of the convex mirror. This is the case of the convex mirror. Okay, so this is principal axis. When the rays of light parallel to the principal axis, after reflecting, they reflect back into the same type. But if we extend these one, they appears to coming from the focus. So this is so that's why these types of mirrors are called diverging because they do not converge at a point. They are diverging. They are not meeting at a point. That's why they are called the diverging mirror. The other name of the convex mirror is the diverging mirror. Now I'm talking about focal length, and focal length is denoted with F. Remember, there is a difference between principal focus, and the focal length. Principal focus is denoted with capital F, and focal length is denoted with small f. You should be very careful because there is a difference. There is a huge difference between the principal focus and the focal length. The focal length is small, f denoted with small f, and the principal focus is denoted with capital F. So the distance, it is the distance from the pole to the principal focus. So from this side, this point to this point, from pole to the principal focus, the distance from pole to the principal focus is denoted with small f. Look, you can see this is the small f. This is called the principal focus. This is called the focal length. The distance from the pole to the capital F, the principal focus, is called focal length, and it is denoted with small f. It is the distance from the pole to the principal focus made along the principal axis, and this is principal axis. Okay, so this means that as the radius of curvature is reduced, so 2 is the focal length of the reflecting surface. So if the radius of the curvature and there is a difference, and there is a formula between focal length and radius of curvature. So the radius of curvature and focal length are linked with the formula F is equal to R by 2. We will use this formula in our numericals. So you should be very careful when you should be memorize this by heart. There is a relation between the focal length and the radius of curvature, and they are linked with the formula F is equal to R by 2. Half of R. Okay, focal length is half of radius of curvature. So now I discuss the characteristic of both convex, not the lens, convex mirror and the concave mirror. So convex mirror, so and the concave mirror. This is my concave mirror and this is my convex mirror. So there I'm going to study the characteristic of focus of concave and convex mirror. Concave mirror, the focus is in front of the mirror. Look, the focus in front of the mirror is here. The focus is in front of it. The focus is real as the rays of light and after reflection converge at a focus. Look, after rays of light, when you strike them, they converge at a point. So in this case, the focus is real and the rays of light after reflection converge at a focus. Look, they are meeting at a point. So that's why this is called concave mirror. Convex mirror, the focus lies behind the mirror. Look, the focus is behind the mirror. The reflecting surface is this one. So the focus is at the back. So it means this is behind the mirror. The focus is virtual as the rays of light after reflection appears to come from the focus. They actually diverge. This is called diverging mirror. So they appear, if you extend this one, they appears to coming from the focus. So these are the characteristic of both convex mirror and the concave mirror. Okay. Reflection of light by a spherical mirror. Like plane surfaces, spherical mirror surfaces also reflect light following in two laws of reflection as stated by plane. As I have already discussed the laws of reflection, incident rays, normal, and the reflected rays lie in the same plane. Angle of incidence must be equal to angle of reflection. This is the law of reflection. Shows this look. This is the laws of reflection. Convex mirror. This is the concave mirror. So why I'm saying convex mirror and concave mirror? Because in concave mirror, the inner surface is reflecting and outer surface is polished. In convex mirror, the inner surface is polished. This blue shows this is the polished surface, and outer surface is reflecting. So they shows light is shows light shows how light is reflected by the spherical surface of concave and convex mirror according to the laws of reflection. Look, I told you laws of reflection, angle of incidence, incident ray, reflected ray, and the normal lies in the same plane. Angle of incidence must be equal to angle of reflection. This is called the law of reflection. The reflection of light by spherical mirrors. So this is called the convex mirror, and this is called the concave mirror. So students, this is the end of the topic 12.2. So I will give you what we studied. I will give you a brief description what we studied. Uh, we studied in this chapter uh, laws of reflection, and then we studied phenomena of laws of reflection. What is reflection of light? Then first of all, I give you the definition of reflection of light. Then we studied law of reflection, normal incident ray, normal ray, reflected ray, all lie in the same plane, and angle of incidence must be equal to the angle of reflection. Then we studied types of reflection. There are two types of reflection: regular reflection and irregular reflection. Regular reflection is generated from the smooth surfaces, while irregular reflection is generated from the irregular surfaces which are not smooth. Then we studied about 12.2 spherical mirrors. So we studied about concave mirror and convex mirror. The spherical mirror whose inner curved surface is reflecting is called concave mirror. In concave mirror, the size of the image depends on the position of the object. Both virtual and real images can be found by the concave mirror. So this is the concave mirror, this is the convex mirror. In this case, the inner surface is polished, inner surface is reflecting, and outer surface is polished. But in convex mirror, the inner surface is polished and the other outer surface is reflecting. This type of mirror is called convex mirror. So then we studied the important terms related to this mirror. We studied about convex mirror, pole, what is pole, center of curvature, what is center of curvature, what is radius of curvature, and we studied what is principal axis, principal focus, then focal length, and we studied about these things, and we also studied that convex concave mirror is also called converging mirror, and convex mirror is called diverging mirror. So then reflection of light. So reflection of light, these mirror follows the laws of reflection. So incident ray, normal ray, and the reflected ray lies on the same plane. Angle of incident must be equal to angle of reflection. So angle I, in this case, you can see angle I is equal to angle of reflection. This is the second law of laws of reflection. And angle of incident, angle of reflection, and normal lies on the same plane. So in both cases, we discussed about the laws of reflection. So this is called convex mirror. Why I'm saying convex mirror? Because the blue line shows this is the polished surface. The outer surface is called reflecting surface. But in this case, concave mirror, the inner side is reflecting and the outer side is polished. So in this case, both the mirrors, the concave mirror, whether it is a concave mirror or convex mirror, they follow the laws of reflection. Laws of reflection are what are the laws of reflection? The laws of reflection are angle of incidence must be equal to angle of reflection, incident ray, reflected ray, and normal lies on the same plane. So students, this is the end of the both the topics 12.1 and 12.2. So I hope you understand this. If you have any question regarding this, you can feel free to ask the question. So your homework is please memorize the topics by heart and write once on rough register. So you need to write them. First of all, memorize them. Uh, in few days time after this, uh, we will do a task. So you memorize the topics and I will listen sometime. So side by side your job is to memorize them, and in my other lectures I will try to listen from you. So uh, make sure you side by side learn these topics. So your topic is please memorize the topics by heart and write once on your draft register. So if you have any questions regarding this, please feel free to ask. Thank you.